everyone, in this video I'd like to go through the task for Module 7. So we are asked to model a drum that has sides shaped like a hyperbola, and the total height of the drum is 26 inches. And the diameter at the top of the drum is 16 inches, the minimum diameter is 7 inches, which occurs at a height of 9 inches. All right, let's take that information and draw a picture. Okay, so I'm going to draw a drum, and it's going to have a circular top here. It's kind of shaped like a hyperbola, and then it has a circular bottom, and there's that minimum diameter. And the information that we're given is that the total height of the drum is 26 inches. So I'll just put that measurement right there. They tell us that the diameter around the top of the drum, this is 16 inches. So that means that the radius would be 8. Some other information they give us is that the minimum diameter is 7 inches. So this diameter is 7 inches. Or again, if I look at the radius, is 3.5 inches. And that minimum diameter occurs at a height of 9 inches up. So if we subtract the 26 minus 9, that would tell us that this missing piece here is 17 inches. Okay, so what does that mean in terms of graphing? Well, first of all, we have some coordinates here. I'm going to graph this with my minimum diameter right here along the x-axis, because that's just going to make my life a lot easier. So I'm going to put this at 3.5 and negative 3.5. And so then my hyperbola is going to, do whatever it does. I'll set the base down here 9 inches below. So this is going to be 9 inches below. The y coordinate there is going to be negative 9, whatever the x is. I don't really care at this point. And some other x value, I'll call it x1 and maybe x2. We've got these points here. This is going to be over 3.5 up 0, over negative 3.5 up 0. And then here's the really important one. Up here on the top edges of that drum, I'm going to need a radius of 8. So I need to go over 8 units in the x direction, and then I need to go up 17 inches beyond that minimum diameter. So whatever hyperbola I come up with, it's got to pass through those points 8, 17, and negative 8, 17. Now, a lot of people have come up with the idea so far that we've got x squared over 3.5 squared. And that's coming right here from our minimum diameter or those vertices. But then the question is, what happens to the value below y squared? Well, what you can do is you can plug in these points, 8, 17, and figure out what you need that value to be. So if 8 is going in for x, I'm going to have 8 squared over 3.5 squared minus y, that's going to be 17 squared, over whatever this question mark is. I'll leave it as a question mark for the moment. And so what you need to do is you need to solve this equation. You could use calculator, Wolfram Alpha, or pencil and paper it out. But you need to solve that for that missing value. Once you have that, we can go over to Desmos to make sure that it works. Now in the form, I do have a sample code here I posted it in a reply to Kiwi. So here's a little graph. We can take a look at that. And then this link to Desmos shows you the code that I used. So there's the 3.5 squared down in the denominator for x squared. And here's a big hint of what the answer is for the problem this week is 8.27 squared down there in the denominator for y squared. Now, if we take a look at some points on this curve, we are seeing that value 8, 17, and then the other one here, which is negative 8, 17. And then our minimum diameter here is the 3.5 and the negative 3.5. And then our lower edge of that drum is down below the x-axis by 9 units. This is not the only way to solve the problem. So if you've shifted everything up a little bit, that's fine, but you do need to make sure that the top edge of your drum is given the correct diameter, the minimum diameter is here, and that you've got the correct total overall height.